Okay, this is the solution for question 1 of the chapter 12 worksheet. All right, if you look at question 1, you'll see that you're given data on 4 different groups. So when you're given raw data, when you're solving for an ANOVA, these are the steps that I recommend that you take. So the first step is you want to get the mean of each group. Okay? Add all the numbers together per group, divide by the amount of numbers in each group, and get the mean for each group. All right, there you go. 11, 6.67, 5, and 14.33. All right, the next step is to get the grand mean. The grand mean is the mean of all 4 groups together. So if you add up all of the individual means, that equals 37. Divide by 4, because there's 4 groups, and that equals 9.25. All right, it's important to get this information because you will need this information to solve for sum of squares between and sum of squares within. The next step is I want you to get degrees of freedom between and degrees of freedom within. To get degrees of freedom between, if you look at your formula sheet, it says it's k minus 1. All k represents is the number of groups. So in this case, there's 4 groups, minus 1 equals 3. So degrees of freedom B, or degrees of freedom between, equals 3. The next step is you want to get the degrees of freedom within the groups. That's done by taking the degrees of freedom from each group individually and adding them up. Well, we will be working with equal groups, and in this case, each group had 3 participants in it, so that means each group degrees of freedom is 2. There are 4 groups, each with a degrees of freedom of 2, so 4 times 2 equals 8, or 2 plus 2 plus 2 plus 2 equals 8. Okay, once you have this information, you're going to solve the 2 most critical parts of the ANOVA formula to eventually get your F obtained. So the first step is to solve the sum of squares between. Okay, so you're going to multiply by the number of participants in the group, and you're going to times that by each individual group mean minus the grand mean squared. So you have to do this process first. And then once you have that number of all these deviation scores added, then you multiply it by 3, or by the number of participants per group. So in this case, first mean is 11, so 11 minus 9.25 squared is 3.0625. 6.67 minus 9.25 squared is 6.6564. Third group, fourth group. All right, you have the 4 deviation scores. You add these scores up, and that will give you 53.5878. Now you have to do that multiplication by 3 at the end of that. So now when you take this number, multiply it by 3, your sum of squares of B is 160.7625. Now I've done this question without rounding. However, you could do it the same way, rounding to 2 decimal points. That works fine. The second step is you have to solve for sum of squares within. Now sum of squares within is simply the sum of each sum of square per group. So we've done sum of squares throughout the semester numerous times, so I did not show that work here. However, when you do it by yourself at home, you should come out to these numbers. If you do the sum of squares for group 1, you should get 2, 2.67 for group 2, 6 for group 3, and 4.67 for group 4. Now, to solve for sum of squares within, you simply add the 4 sum of squares up. Okay, now you have everything you need to solve for MS between and MS within. MS between, if you look at your formula sheet, is simply sum of squares between divided by degrees of freedom between. So when you take the sum of squares between number, 160.7625, and divide that by your degrees of freedom between, which is 3, you will get MS between, which is 53.5875. MSW, same concept. You're going to take the sum of squares within divided by the degrees of freedom within, and you're going to get mean squared within, which is 1.9175. Once you have these two numbers, refer to your formula sheet that I posted on Blackboard. Now you take the mean squares between and divide it by the mean squares within. So if you do 53.5875 divided by 1.9175, you will get an F obtained of 27.9. Okay. Now, just like t-tests, we have to compare this obtained value to a critical value and make a decision on a null hypothesis. So in this case, the F critical comes out to 4.07. Okay, you know this when you go to page 705 in your textbook, you will see on the horizontal frame, it's for the numerator, and then on the vertical frame, it's for the denominator. So that basically just means you're looking at degrees of freedom between and degrees of freedom within. So in this case, that's 3 and 8. So if you go to 3 on the F chart, going along the horizontal plane, and go to 8, going down the vertical plane, you'll see two numbers. One of them is in bold and one of them is not. The number in bold represents a critical value at the alpha level of 0.01. We don't want that. This question's asking for 0.05. So when we're looking for a 0.05, we are looking at the non-bolded number. So if you go over 3 and down 8, non-bolded, you will see 4.07. Now, 4.07 is a lot less than 27.9, our obtained value. So what do? We know this is a significant result, so we will reject the null hypothesis. That's how you do question 1.